Hello everyone, hello lovely students, welcome back to this video session. Hope you all are doing great in your life. My name is Ashwant and I'm from India, which happens to be a very awesome, wonderful country. And today I have got a really exciting math lesson for you all. Want to know what's that? Then please don't skip and make sure to stay with me all around till the end. Here we go. So for today's session, we have got these problems, and for solving these problems you have to be familiar with the concept of wavy curve. And to some of you it might sound a little strange who have come across this for the first time, and perhaps many of you might be knowing it in advance. Alright, so wavy curve is a curve that gives you an idea about the sign change of the expression. What it actually means is, with the help of this curve you get to know when your expression achieves positive value, when it achieves negative value, and when it achieves zero, and also when it is not defined. I would also like to specify here that wavy curve is not the exact curve or the actual graph of the given expression. The actual graph looks very different from this wavy curve. This wavy curve gives you an idea only about the interval of the positivity or the negativity of the expression. Now let's understand the working rule. To draw a wavy curve, our expression must be of the following forms. So we have got two cases, and if you observe the structure of the expression in both the cases carefully, you'll understand that the expression contains only linear factors. You can see here, you can have a look that in case 1 we have got linear factors in the numerator and the denominator both, or we can have an expression where the linear factors are present only in the numerator, or we can have an expression where linear factors are present only in the denominator. Same goes for case 2 as well. The expression of case 2, you can see we have linear factors in the numerator and denominator both. And these two expressions as well, we have linear factors only in the numerator and we have linear factors only in the denominator. And the power or the exponent of the linear factors p1, p2, pn I have used to represent the power or the exponent for the linear factors in the numerator, and to represent the power of the linear factor in the denominator, I have used symbols q1, q2, so on up to qn. These are all whole numbers. Alright. There's one more important thing that I would like to specify here. In the beginning of all the expressions in case 1, you see a positive sign. You can see here, we have a positive sign in the beginning of this expression, as well as this expression, and this expression as well, we have a positive sign in the beginning. And for all the expressions in case 2, we have a negative sign in the beginning of all the expression. This is a very important point to note down here. This is the only thing that differentiates the expressions of case 2 from case 1. Hope you all understand. Now there are a few steps that you have to follow to reach the final wavy curve. Step 1, get the critical points, arrange them in ascending order and plot them on the number line. Now many of you would be wondering what are critical points and how do we get them? Well, for this we have an expression. Let's have a look here. Let's say we have an expression that looks somewhat like we have x minus 3 as the linear factor in the numerator, and in the denominator we have two factors, linear factors, x minus 2 into x minus 5. Now to get the critical points, we equate all the linear factors present in the numerator or denominator or both. Like in this case, our expression has linear factors both in the numerator as well as denominator. So for getting critical point, we equate all the linear factors to 0. Like if you equate x minus 3 to 0, you get 3. If you equate the linear factors present in the denominator, you get 2 for this one, and for this one you have 5. There's one more important point that I would like to specify here. For all the critical points that you get corresponding to the linear factors in the numerator, the expression achieves value 0. And for all the critical points that you get corresponding to the linear factors present in the denominator, like here, your expression is not defined. So critical points are those points at which the expression achieves value either 0 or it is not defined. Just I'll show you. Like the critical point 3 you get corresponding to numerator, and the critical point 2 and 5 you get corresponding to the denominator. So if I put the critical point 3 in the expression e of 3, so we have 3 minus 3 upon 3 minus 2 into 3 minus 5. So 0 upon 1 into minus 2. So 0 upon non-zero will be 0. And if you put any value 2 or 5 in the expression you will see, let's say you put 2. So if you put 2, it is 2 minus 3 upon 2 minus 2 into 2 minus 5. So 2 minus 3 is your minus 1, and 2 minus 2 is 0, 0 into minus 3. So it is minus 1 upon 0. So division by 0 is not defined. Hope you understand. So in step 1, we have seen that we have found the critical points by equating all the linear factors present in the numerator or denominator or both to 0. Now in steps 2, we plot the critical points on the number line in ascending order. Now for doing that, we have to be very careful, like for the critical points that we get corresponding to the linear factors present in the numerator, like in this case we have critical point 3 that corresponds to the linear factor x minus 3 in the numerator, and the critical points 2 and 5 they corresponds to the linear factor x minus 2 and x minus 5 in the denominator. So the critical points that are corresponding to the numerator, we mark them using a filled circle on the number line. You can see I have marked 3 on the number line using a filled circle. And for the critical points that you get corresponding to the linear factors in the denominator, like in this case we have 2 and 5, so I have marked them using open circle. You can see there, here we have open circle for 2 and 5. Now why is it so? Is it so because for the critical points in the denominator, when you put these values of x in the expression, you will see that your curve or the expression is not defined. So open circle is a way to represent that the curve or the expression value is not defined at these values or these points of x. So in step 2, we have marked the critical points in ascending order on the number line using a filled circle or open circle, depending on whether we are getting the critical points from the linear factors of numerator or we are getting the critical points from the linear factors of the denominator. Now this will become more clear when we'll take some illustrations, but let me just finish this all steps once for you all. So moving forward to step 3, now there are 2 scenarios. We'll start drawing the curve, but there are 2 scenarios that we have to be careful of. Our expression can be either of this form or it can be of this form. First of all, whenever you come across an expression for which you want to draw a wavy curve, you have to make sure that your expression contains only linear factors, and that also they must be expressed in the product form. So they have to be in the product form in the numerator or denominator or both. Like in this case, we have linear factors in the numerator and denominator both for both the expression. And secondly, you have to make sure that in all the linear factors, the coefficient of variable, which in this case happens to be x, it's plus 1. Like we have plus x and plus x. And in this expression as well, we have plus x and plus x in all the linear factors. And lastly, our expression, we have to check for a positive sign. Like in this case, we have a positive sign, and in this case, we have a negative sign. It's a way to differentiate that our expression belongs to case 1 or it belongs to case 2. And case 1 and case 2, I have already discussed a couple of moments back. Okay, you can pause the video, you can rewind the video, and you can have a look. Alright, so we start drawing the wavy curve from the right side of the rightmost critical point. From the right side of the rightmost critical point, I repeat, with a positive sign, and above the number line if we have a positive sign in the beginning of expression. Like if we start drawing the wavy curve for this expression, we'll start drawing from the right side of rightmost critical point. The rightmost critical point is 5, and from the right side we'll start, and above the number line with a positive sign, because we have a positive here in the expression. For this scenario, because we have a negative sign, we'll start drawing the curve from the right side of the rightmost critical point with a negative sign and below the number line. The negative sign. Okay, and just concentrate here for the first expression. We reach 5. Now reaching 5, we have to decide whether we should change the sign of curve from positive to negative or the curve should stay the same as it is. That actually depends on the power of the linear factor that corresponds to 5. The linear factor corresponding to 5 is x minus 5 and its power is 1. So we usually don't write a power 1 for a mathematical quantity, but by default if it is not written, it is taken to be 1. Hope you understand. So if the power is odd, the curve will change its sign, and if the power is even, the curve will not change its sign. So because 1 is an odd number, so the curve will change its sign from positive to negative. Okay, and Now again at 3, we have to decide whether the curve should change its sign or it should not change its sign. So 3 corresponds to x minus 3 and the power is again 1 here. It's not written, so by default we take it to be 1. And 1 is an odd number, so we'll change the sign from negative to positive. And again at 2 we'll change the sign to negative because you can see here the power is odd. Now the same logic goes for this expression as well. We change the sign because all the powers are odd, and when all the powers are odd we change the sign alternately, positive to negative or negative to positive. So we keep doing this and we get the wavy curve for our expression. Now what's the significance or what the message this wavy curve conveys us? Let's try to understand. Like in this case, if I talk about the number line is running from negative infinity to positive infinity. So in this case, the wavy curve for this expression gives us a message that for the interval or the values of x that belongs to the interval negative infinity to 2 and 3 to 5, if you put any value of x from this interval in the expression, this expression is gonna generate a negative value or a negative output. You can take any value from this interval and you can just verify it now. Let's say I put value 1 because 1 lies in this interval negative infinity to 2, and let's see what happens. So if I find e of 1 minus 3 upon 1 minus 2 into 1 minus 5, so we have minus 2 in the numerator, minus 1, and this is your minus 4. So we've got 3 negative signs. So when we have 3 negative signs, the final value will be negative in nature. Because we are not concerned with the actual value of the expression, we are only concerned about the positivity and the negativity of the expression. Now this is what wavy curve tells us actually, and I have already spoken all these in the beginning. So we have a negative, and this is what we're supposed to get. And also if you put any value from this interval 3 to 5, because the wavy curve is below the number line and we have a negative sign here to represent that all the values that we will get for the expression will be negative nature. Alright, similarly if you take any value of x from this interval 2 to 3 or 5 to positive infinity, and you put in the expression, you will find that the expression will generate a positive value or a positive output because the wavy curve for this interval is above the number line, and the positive sign represents that the curve will generate positive output or a positive value. Now let's understand what the second wavy curve is conveying the message. So if we talk about the second curve, let me mark just this number line is running from negative infinity to positive infinity. So similarly like in this scenario, for this scenario as well, if you take any value of x from negative infinity to 2 and from 3 to 5, if you put any value of x from this interval in our expression, you will find that this expression will generate a positive value or a positive output, because for this interval or for these values of x, the wavy curve is above the number line, and the plus sign is a way to represent that the curve will generate only positive values for this interval or for these values of x. Now, if you take any value of x from the interval 2 to 3 or from 5 to positive infinity, because the wavy curve is below the number line and we have a negative sign, so the wavy curve or this expression will generate a negative value or a negative output if you put any value of x from this interval. So this is what your wavy curve actually tells about. And you can see here the filled circle, we don't have a point on the curve because a filled circle, I'm very sorry, actually it's an open circle, I should say open circle. So at open circle we don't have a point on the curve or the graph, because open circle is a way to represent that the curve value or the graph value or the expression value does not exist at those points. And the filled circle where the curve intersects the number line, it's the point actually where the curve achieves value 0. Hope you all understand whatever I've just said. Okay, so before we move forward to the illustrations, I would just again like to repeat, there's one more important point I have already said, but still I would like to repeat because it's very important. So it's about the sign change of the wavy curve. So whenever while drawing the wavy curve you reach the critical point, you have to decide whether you should change the sign of the curve from positive to negative or from negative to positive. that actually depends on the power of the linear factor that corresponds to that critical point. I repeat, you have to look at the power of the linear factor that corresponds to the critical point. Now that power, if it is odd, you will change the sign. If the power is even, you will not change the sign. Like in this case, you see here, we have changed the sign alternately because all the linear factors, they have odd power. The power is 1 for this expression as well as for this expression. Alright, now we move ahead to our illustrations to get a better clarity and a better understanding of what we just talked about. Now let's have a look at some illustrations. We'll talk about some of the interesting illustrations to understand what we actually just talked about, all the wavy curve. Okay, so for this purpose, let's say we have an expression, a very simple expression, x minus 2. And we want to draw the wavy curve for this expression. This expression actually belongs to case 1. You can just rewind the video and you can see the structure of case 1. So we have only one linear factor, and they're also only in the numerator. And we have a positive sign in the beginning of this expression, as well as the coefficient of the variable is plus 1. So we mark the critical point 2 on the number line with a filled circle, because for the critical point that corresponds to the factors in the numerator, we mark them using filled circle on the number line. And we start drawing the curve from the right side of the rightmost critical point. We have only one critical point, so it will be the rightmost. So we start drawing the curve from the right side with a positive sign and above the number line. And we change the sign at 2 from positive to negative because the power is odd, it's 1 actually. So we have this wavy curve, and you can see here as well, for all the values that lies on the right side of 2 on the number line, if you put these values of x in the expression, this expression will generate a positive value or a positive output. It's very simple. You can see, like, you put 3, 3 minus 2 is 1. You can put 5, 5 minus 2 is 3, all the positive values. And if you put any value of x from the left side of 2 from the number line, you'll find that this expression generates a negative value or a negative output. Okay, now let's move to our second illustration. This is our first illustration. Now let's have a look at our second illustration. Let's say we have an expression x minus 2 into x minus 5. Now this expression as well, it belongs to case 1, because all the linear factors, we have a positive sign of the variable plus x, and we have this plus sign to decide whether we should start the curve from above the number line or from below the number line. So we mark the critical points on the number line. 2 and 5 are the critical points, and we have marked them using filled circle because all these critical points are corresponding to the numerator. And we start drawing the curve from the right side of the rightmost critical point from above the number line, because this expression belongs to case 1. So whenever our expression belongs to case 1, or if we have a structure that is very similar to case 1, we always start drawing our curve from above the number line with a positive sign. And because all the power is odd here for all the factors, so reaching the critical point, you will change the sign alternatively from positive to negative and from negative to positive. So this is the wavy curve for this expression. Alright, now what if for the same expression, let's say if we were having a negative sign over here, just I'll draw the wavy curve for this expression. Let's say this is our illustration 3. So we have an expression with a negative sign, negative of x minus 2 into x minus 5. I am repeating again and again the steps or the working rule of wavy curve so that you guys get accustomed to all this. So first of all, we have to make sure that in the expression the linear factors are expressed in the product form, which is okay here. You can see that the linear factors are expressed in the product form, and in all the linear factors the coefficient of the variable, which in this case happens to be x, is positive 1. We have plus x here and we have plus x here. And lastly, to differentiate that whether the structure belongs to case 1 or case 2, we have to look for the positive or negative sign in the beginning of the expression. Like in this case, we have a negative sign, which actually tells us that this type of expression should be drawn according to the rule of case 2. So first of all, let's draw the number line. We mark the critical points using filled circle. 2 and 5 are the critical points. Now because we have a negative sign here, we start drawing the wavy curve from below the number line with a negative sign, and as all the powers are odd here, we have 1 for all the linear factors. The power is 1, which is odd. So we change the sign from negative to positive and from positive to negative. The number line is running from negative infinity to positive infinity, and you all can verify that this curve will give you negative values for negative infinity to 2 and from 5 to positive infinity, and for this interval 2 to 5 this expression will generate a positive output. Hope you understand. Now let's talk about one more illustration. Let's say if we have an expression that looks somewhat like x minus 2 upon x minus 5, and we have to draw the wavy curve for this expression. So first of all, we make sure that all the factors in the numerator and the denominator, they are expressed in the product form and they are linear. So we have got linear factors in the numerator and denominator as well, and the coefficient of the variable has to be plus 1. So we have plus 1x here, and in the denominator as well we have plus 1x. Lastly, we look for the positive sign or the negative sign in the beginning of expression to differentiate whether the expression belongs to case 1 or case 2. So we have a positive sign here. Now we find the critical points by equating all the linear factors to 0. So we have 2 and 5 as the critical points. 2 corresponds to the numerator and 5 corresponds to the denominator. The number line is running from negative infinity to positive infinity. We mark 2 on the number line with a filled circle because it corresponds to the numerator, and we mark 5 using open circle because this critical point corresponds to the factor in the denominator. Now because our expression, we have a positive sign in the beginning and it belongs to case 1, we start drawing the wavy curve from above the number line with a positive sign, and all the critical points, their linear factors, they have odd power. So we'll change the sign when we reach all the critical points. Okay, so this is the wavy curve for this expression, and it tells you that from this interval negative infinity to 2 and from 5 to positive infinity, you will get positive values if you put in the expression any value of x from this interval. If you put in the expression will give you a positive output, and for any value of x in this interval 2 to 5, if you put in the expression, that this expression will give you a negative value or a negative output. What if this same expression, if we have a negative sign? Okay, let's change this expression slightly. Let's say we have one more factor like x plus 7 here. Okay, so first we'll look to satisfy all the constraints for drawing the wavy curve. The expression must contain only the linear factors, so we have only the linear factors, and that also the coefficient of the variable has to be plus 1, so you can check for that as well, and it's fine here. We have plus 1 for all the for all the coefficient of x, we have plus 1, and we find the critical points by equating the linear factors to 0. So we have minus 7, we have 2 and 5. So minus 7 and 5 are the factors that corresponds to the are the linear factors that corresponds to the denominator, and 2 is the critical point that corresponds to the numerator. I am identifying all this because while marking them on the number line, you have to be careful about the fill and the open circle. So we have this number line which runs from negative infinity to positive infinity. We mark the critical points in ascending order on the number line, and for the denominator critical points, we have open circle. For the numerator points, we have filled circle. Okay. Now because in the beginning of expression we have a negative sign, so this expression or this structure will follow the rules of case 2. And case 2, we start drawing the curve from right side of the rightmost critical point from below the number line with a negative sign. Unlike this situation, because we have a positive sign here, we started drawing the curve from above the number line with a positive sign, but for this expression, we'll start drawing the curve from below the number line with a negative sign. Now we'll change the sign alternately, negative, positive, negative, and then again. So this is the wavy curve for this expression. Okay. Now we take some more illustrations. Let's take one more illustration here. Let's say we have e of x is equals to 1 upon x minus 2 x minus 5 and x plus 7. Okay, and let's say we have a negative sign here. So this structure, now you might have got the answer. This structure actually belongs to case 2 because all the linear factors are present in the product form, and the coefficient of the variable x is plus 1 in all the linear factors. You can just verify here. And also we have a negative sign in the beginning, which actually tells us that this structure belongs to case 2. So we mark the critical points on the number line, but before that we find the critical points by equating all the linear factors to 0, and we arrange them in ascending order also. So we have minus 7, 2 and 5, and all these critical points are corresponding to the denominator. These all critical points, they are corresponding to denominator. So when we mark them on the number line, we have negative infinity here, we have positive infinity here. The number line runs from negative to positive infinity. So we mark all these critical points on the number line, negative 7, positive 2 and positive 5 with an open circle, because for all these critical points or these values of x, if you put in the expression, the denominator of the expression will be 0, and the expression or the curve or the graph will not exist. So that's why we have open circle. Now we start drawing the curve from below the number line with a negative sign, and we change the sign alternately because all the linear factors, they have odd power. So odd and even power is the deciding factor for the sign change of the expression. If the power is even, we don't change the sign. If the power is odd, we change the sign. So for all the linear factors, we have odd power, so we keep changing the sign. Okay, so this is the final wavy graph for our expression. Alright, now we take some more illustration. Now we'll increase the power of the factors in the expression. Let's say we have an expression e of x is equals to x minus 4 and x plus 2, and let's say we have x minus 5. Okay, let's say we have x plus 4 and power 3, power 4 and power, let's say we write 11. So let's say we have this expression and we want to draw the wavy curve for this expression. So first of all, we make sure that all the linear factors are present in the product form, which is okay here. Secondly, we make sure that all the coefficient has to be plus 1. So we have plus x and plus x in all the expression. And lastly, we check for the positive or negative sign. So we have a positive sign in the beginning of this expression. It's not written actually here, but by default it's taken to be positive if the sign is not mentioned. We mark the critical points. Before that, we find the critical points by equating all the linear factors to 0. So we have minus 4, then we have minus 2, and then we have 5. And because all these linear factors are corresponding, all these critical points are corresponding to the linear factors in the numerator. You can see here in this expression we don't have a denominator. So we mark all the critical points using fill circle. The number line is running from negative infinity to positive infinity. We have minus 4 here, we have then minus 2, and then we have 5 here. So because we have a positive sign in the beginning of expression, we'll start drawing the curve from above the number line with a positive sign. We change the sign from positive to negative because the power of the factor that corresponds to 5 is odd, is 3 here. Now when we reach minus 2, the minus 2 critical point corresponds to the factor x plus 2. Its power is even, you can see here it's 4. So we don't change the sign. So negative will remain negative. Now when we reach minus 4, we have to decide again whether the curve should change its sign or it should remain the same. So minus 4 is corresponding to x plus 4, its power is odd. You can say the factor, the linear factor corresponding to minus 4 x plus 4, its power is odd, it's 11 actually. So we change the sign from negative to positive. And now this is the final wavy curve, and you can verify what the message is this curve conveying us. So if you take any value of x that falls in the interval minus 4 to minus 2 and minus 2 to 5, this expression will generate a negative value or a negative output because the wavy curve is below the number line, and the negative sign represents that the curve will generate or the graph will generate a negative output. You can verify, like if you put any value from this interval, let's say minus 2 to 5, what can we put? Like we can put 3 in the expression. So let's find E of 3. What's happening? So 3 plus 4, 11, 3 plus 2 to the power 4, and 3 minus 5. Don't be afraid of the values. We are not going to find the actual value. We are just only concerned about the positivity and negativity of the expression. So it's 7 to the power 11, it's 5 to the power 4, and it's minus 2 to the power 3. So 7 to the power 11 is positive, 5 to the power 4 is positive, and minus 2 to the power 3 is a negative. So positive into negative, the final value will be negative. And this is what we are actually supposed to get, because the curve is below the number line. And you can verify for other intervals as well, because wavy curve never gives you a wrong idea about the positivity and negativity. It always gives you the right idea about the positivity and negativity if you have not made any errors while drawing. Hope you understand, all my lovely students. Okay, now let's take our last illustration. For the same expression, just, yes, wait, went. Okay, we have what we have, x plus 4, x plus 2, and x minus 5. Okay, let's say if we have something like E of x is equals to, let's say we have x plus 4 to the power 11 and x minus 2, sorry, x plus 2 to the power 4 and x minus 5 to the power 3. Okay, let's say we have this expression, and let's say we have a negative sign also here. We have to draw the wavy curve for this expression. So first step, we make sure that all the linear factors are present in the product form, which is okay here. Then we check for the coefficient of the variable in all the linear factor. It has to be plus 1, so we have plus 1x, plus 1x, plus 1x. And lastly, we look for the positive or negative sign in the beginning of the expression to differentiate whether we have to follow the working rule of case 1 or case 2. So we have a negative sign here, so we follow the working rule of case 2, and we'll start drawing the curve from below the number line, from the right side of the rightmost critical point. First, let's find the critical point by equating all the linear factors to 0, as well as we'll write the critical points in ascending order. So we have minus 2, then we have minus 4, and then we have 5. Identify the critical points that corresponds to the numerator and that corresponds to the denominator for filled circle and open circle. So for minus 2 and 5, these are corresponding to the denominator. So we mark them using open circle on number line. And the minus 4, it's filled circle. So we draw the number line. And we mark the critical points. So minus 2 we mark using open circle, minus 4 we mark using filled circle, and 5 we mark again using open circle on the number line. Now we start drawing the curve from the right side of the rightmost critical point, and because we have a negative sign, so we start doing the curve from below the number line with a negative sign. Just I want you all to recall what we did in this previous illustration. Okay, it's actually not working properly. Just I'll show you what we just did. You see in this previous expression, because we have a positive sign here, so we have we started drawing our curve from above the number line. Okay, we have a positive sign in the beginning, and for this expression, you can see we have a negative sign in the beginning. So we start drawing the curve from below the number line, and 5 x minus 5 has odd power, so we change the sign from negative to positive. So we have a positive sign here, and minus 4, right? There is some mistake, I think. X plus, okay, sorry, I have done a little mistake while marking the points on the number line. This is actually minus 4 with a filled circle, I think, and this will be your open circle, and this will be your minus 2. Just let me once verify this as well. If I have not done, yes, that was okay. Okay, so yes, now at minus 2, we don't change the sign because the linear factor x plus 2 that corresponds to minus 2 has even power. You can see the power is even. So the power is even, so positive sign will remain positive. Now at minus 4, for this critical point, minus 4, we have to change the sign because the linear factor corresponding to minus 4, x plus 4 has odd power. So this is odd and this is even power and this is again odd. That's why we have changed the sign over here for x minus 5. So we change the sign from from positive to negative. So we have this Wavy curve and you can verify the number line is running from negative to positive infinity. You can verify if you put any value of x from negative infinity to minus 4 or from 5 to positive infinity in the expression, you'll see that the expression is generating a negative value or a negative output. And if you put any value of x from this interval negative 4 to minus 2 or from minus 2 to 5, the expression will generate a positive value or a positive output. And at minus 4, because we have a filled circle and the curve intersects the number line, the expression will achieve value 0. And for minus 2 and 5, we have open circle, so the expression will not be defined. So this was all about Wavy curve. Now after understanding the Wavy curve, let's get back to the question that we have to discuss for today's session. So we have the first question and we have to find domain for all these three questions. So for the first question, we have to find the domain. Our first question is we have f of x is equals to square root of x minus 3. So you all must be knowing that whenever we have a square root expression and we have to find the domain, domain actually means we have to find those values of the variable that is involved in the expression for which the expression generates a meaningful output. So whenever we have a square root expression and we want to define the square root expression, we have to make sure that the mathematical quantity written inside the square root expression has to be either positive or 0. So we have to make sure that x minus 3 is either greater than or equals to 0. I just want to remind you, I have discussed in my previous sessions that whenever you have a structure that looks like something, means we have some expression written inside the square root sign, and when we have this type of expression, so if we want to define this type of expression, we have to make sure that something is greater than or equals to 0, and if we have this type of structure, the constraint is something greater than 0. We remove the equality sign. There's a reason why we remove the equality sign, because if you put the equality sign, you will also get the values of the variable for which the denominator will become 0. In that situation, the square root is defined. It is not a problem with the square root, because if inside the square root you have a positive value and a 0 value, it is okay. Like in this situation, if you have a 0 for something, it's okay, because inside the square root 0 is possible. We are talking about real values, right? And in this situation, if we have a 0 in place of something, this square root has got no problem, but the overall expression will not be defined, because in maths division by 0 is not defined. So you have to remember that if you have this type of structure, the constraint is something greater than or equals to 0, and if you have this type of structure, the constraint is something greater than 0, we remove the equality sign. Okay, coming back to our solution part. So this structure is, and this one is similar. And if you draw the Wavy curve, or directly you can find, if you draw the Wavy curve as well, we have just learned how to draw the Wavy curve. For x minus 3, we have the critical point and we draw the Wavy curve. So we can see here, this is the Wavy curve for x minus 3. Wavy curve for x minus 3. I know some of you might feel like, why there's a need to draw the Wavy curve. I'm trying to solve this question using Wavy curve because I've just taught you, and I'm just trying to tell you that how using Wavy curve you can find the domain for the square root expressions that involve linear or a quadratic inequality. Otherwise you can directly find from here, like you take 3 on the right hand side, you have x greater than or equals to 3, and in this interval form it will come 3 to positive infinity. But I just want to make you understand that how Wavy curve is also giving you the same solution. So this wavy curve is for x minus 3, and we have to make sure that x minus 3 is greater than or equals to 0. So you can see here that if you take any value of x from the right side of 3, the wavy curve is above the number line. So at a 3, the wavy curve gives you a value 0. So 3 to positive infinity, for 3 to positive infinity, wavy curve is positive or 0 for x minus 3. So this is the domain. This is the domain for square root of x minus 3. What if in the same question, if it were given fx is equals to 1 upon square root of x minus 3. I just told you, like if you have 1 upon square root of something, the constraint is something is greater than 0. We remove the equality sign. So x minus 3 greater than 0. No need to draw the wavy curve because we already have, see the wavy curve for x minus 3. The wavy curve for x minus 3 we have. So for x minus 3 we have the wavy curve. Okay, and now we are interested only in the positive value, right? We are interested only in the we are all interested in the positive, not 0. So if you take any value of x from the right side of 3, excluding 3, okay, because at 3 the wavy curve intersects the number line, so x minus 3 achieves value 0. So wavy curve for x minus 3 is positive for x greater than 3, which in the interval form is 3 to positive infinity, and this is the domain for this expression, this one. 1 upon square root of x minus 3. Hope you understand all. Now let's get back to our second question. Now let's get back to the second question. We have square root of 2 minus 2x minus x square, and we have to find the domain. Okay, so f of x is equals to square root of 2 minus 2x minus x square. So in order to find the domain, we have to define the square root expression, and for that purpose whatever is written inside the square root, we have to make sure that it is positive or 0, because this structure is similar to this one. So we have something greater than equals to 0 whenever we have square root of something. So 2 minus 2x minus x square greater than equals to 0. We have to solve this inequality, and this will give us the domain for this square root expression. It is advisable that whenever you come across quadratic inequalities, you make sure that the coefficient of the highest power of the variable, which in this case is x square, it is positive. So if it is negative, you can multiply it with a negative 1. So when we multiply any inequality by a negative number, we change the sign of inequality. So let's do that. We have x square plus 2x minus 2 less than equals to 0 once we multiply the above inequality by a negative 1. It is also advisable to find the discriminant, because that will give you an idea how to factorize the quadratic inequality, or if it is possible to factorize it or not. So in this case, if I find the discriminant, for that purpose the value of a is 1, the value of b is 2, and the value of c is minus 2, and I expect that you guys are all familiar with the structure of quadratic. It's ax square plus bx plus c. A is the coefficient of x square, b is the coefficient of x, and c is the constant term. So a is 1, b is 2, and c is minus 2. And the d is b square minus 4ac. So 2 square minus 4a is 1 and c is minus 2. So it is 4 plus 8, it is 12. So discriminant is 12. If the discriminant is a positive number, then you can factorize the quadratic ax square plus bx plus c as a times x minus alpha into x minus beta, where you can find alpha and beta using the quadratic formula. Alpha and beta you can find using the quadratic formula, and I hope that you guys are all aware with that formula. The formula is alpha is minus b minus the square root of d upon 2a, and beta is minus b plus the square root of d upon 2a if alpha is less than beta on the number line. Okay, so for this quadratic inequality, for the left hand side quadratic expression that we have, I can write x minus alpha into x minus beta. Actually, I should write a times x minus alpha into x minus beta, but the value of a is 1 here. The value of a is 1 here. Okay, and alpha is less than beta. We assume alpha is less than beta. Now let's try to solve this inequality and get the values of x in terms of alpha and beta. Lastly, we will find the value of alpha and beta using the quadratic formula, but let's first do that. So we draw the wavy curve for this expression. Draw wavy curve for this expression. Now how do you draw the wavy curve for this expression? We have just talked about so much. We find the critical points. The critical points will be alpha and beta by equating the linear factors to 0. Okay, and we use filled circle because we have only numerator. Now we start drawing the curve from the right side of the rightmost critical point, and with a positive sign above the number line, because you see this expression, this belongs to case 1, the structure belongs to case 1. So with a positive sign above the number line, we start drawing the curve, and all the powers are odd here. The power is 1, the power is 1, positive to negative, and from negative to positive, we get this curve. Now what is our requirement as per this inequality? We want that this expression is negative or it's 0. So we are interested in those values of the variable for which this expression is either negative or 0. So when we have the wavy curve, we are supposed to take only that interval or those values of x for which this expression is negative or 0. So you can see here the wavy curve tells us that if you take the values of x from this interval alpha to beta, and including alpha and beta as well, because we want 0 also. So if we take alpha to beta close, this is our constraint, it is satisfied. So this is the final domain or the answer of our question. Now we can easily find the values of alpha and beta using the quadratic formula if you put the values of a, b and the discriminant. So b is actually your 2, and the discriminant is just we have found, I think it was 12. The d, yes, it's 12, d is 12. So square root of d will be, you find the square root of 12, it is actually 2 root 3, I think, yes. So it's 2 root 3, and we have a as 1. So minus 2 plus 2 root 3 upon 2. Then we cancel and we get alpha, and for beta we have minus 1 plus root 3. So x belongs to minus 1 minus root 3 to minus 1 plus root 3. Okay, so we have the answer for this question. The domain is minus 1 minus the square root of 3 to minus 1 plus the square root of 3. That's all. Now let's get back to our last question of today's session. Just have a look what the last question. Yes, we have to find the domain for this expression. Again, we have this structure that looks very similar, square root of something. Okay, now this is our something. So because this expression is inside the square root, so we have to make sure that our something or some expression is either greater than 0 or equals to 0. So we have x plus 3 upon 2 minus x into x minus 5. Okay, we have to make sure that it is greater than or equals to 0. Then only this square root expression will be defined. Now for that purpose, we will draw the wavy curve for this expression, and we will try to find out the interval or the values of x for which this is positive or negative. Now this inequality, okay, just for drawing the wavy curve, we have to make sure that all the linear factors, we have the coefficient of x is plus 1. So you can see in the numerator we have plus 1x, we have plus 1x, but here in the denominator, one of the linear factors we have minus x. So we take minus sign common. So we have x plus 3 upon x minus 2 into x minus 5, and we have a negative sign over here. Okay, it's greater than 0. Now there are two ways. Either you remove this negative sign by multiplying both sides of the inequality with a negative 1, or you can just draw the wavy curve for this expression directly, because I have taught you two cases. In case 2, we were having a negative sign in the beginning of expression. So what I prefer here, I will not multiply it with a negative 1. You can do that, it's your choice, but I will just draw the wavy curve for this expression with a negative sign, just to make you understand that it actually works here. So we have the number line running from negative infinity to positive infinity. Okay, and we have the critical points minus 3, 2 and 5. Minus 3 is corresponding to numerator, 2 and 5 corresponding to denominator. So we mark them using open circle for the critical points that we get from the factors corresponding to denominator, and we plot them in ascending order as well. So minus 3 we have filled circle because it is coming from the factor of numerator, and 2 we have open circle, and 5 as well we have open circle because they are coming from the denominator. Now we start drawing the curve from below the number line, because this structure follows the laws of case 2, because we have a negative sign here. So we draw from below the number line with a negative sign, and we change the sign because all the powers of the linear factors you see here is odd, is 1 actually. So we change the sign, we keep changing the sign, and we have this wavy curve. Now we have the wavy curve for this expression. Now we want this expression to be either positive or 0, So this expression stays positive in the interval negative infinity to minus 3 union 2 to 5. Now we have to also, we can also have 0 for this expression. So 0, we checked for the point where the curve intersects the number line. So minus 3 is the point where the curve intersects the number line. 2 and 5 are not the points, we have open circle. Okay, so open circle, the curve does not exist. So minus 3 we should make it closed because we have to include it. So this is the final answer, or the domain. So that's all for today's session. So this was all about today's session, and I did my best to make you all feel comfortable and happy. If you like my video, then please share it to your friends and loved ones, and make sure to subscribe my channel and hit the bell icon to get the notification of my next upcoming videos. See you all my lovely friends in my next upcoming videos with more exciting and awesome questions. Till then, bye bye, stay safe and have a nice day.